We are going to do the hot ice demo. We're just going to prepare the solution. This is actually a different way than we originally planned to do. We were going to use vinegar and baking soda and make sodium acetate and recrystallize that, but it wasn't really working, to be honest. So I'm going to use like pure sodium acetate, just have a small amount of it, and distilled water instead to see. So we need, to make the full amount, we're going to be needing 160 grams of sodium acetate. I'm not sure if I have that much, but I'll just scale down if I have less. So I'm going to see sort of how much I have. So look at this tiny Erlenmeyer flask. Isn't it adorable? It's so small. It can only hold 50 mils, but that's fine because we only need 30 mils of water. So let's weigh this. And it's 36 grams. I'm going to just tare that. And then I'm going to just slowly add sodium acetate to see how much I have in the container. I'm going to be really careful not to get any on the scale. I know I'm going to need quite a bit. So I'm just adding at a time. So that's only 2 grams right there. So we're going to be scaling this down. That's totally fine.
But Anna had a baby?
No, I might just use a funnel. I have a funnel. Just easier. There we go. I'm going to pour most of it in. Smash it up a bit so it goes through. See how much that is to start. There's 8 grams. I'm just going to keep adding. So I have 20 grams, so that means I'm going to add just under 4 mils of water to this, swirl it around and dissolve it, and that will make it fully super saturated. Just use a smaller graduated cylinder. Get 3.75. Perfect, that's exactly how much I want. So I'm going to add that to the flask. I'm going to swirl it around a little bit, make sure it fully dissolves as much as possible. And we're going to heat this up. I'm just going to use a microwave, and I'm going to heat it for maybe a minute until it's all dissolved and like sort of boiling, and then I'm just going to let it cool. So I'm just going to put it in the microwave and I'll show you what it looks like when it's heated. So it's all heated up. It only took about 25 seconds because it's so small and it's hot. And I'm just going to leave it to sit undisturbed. It's probably going to take about 2 hours. And the slower you can cool it, the better this will work. I'm just going to leave it. I'll be back. This is the second part of the hot ice, which again, I've tried in so many different ways, and I'm out of sodium acetate, so I'm really hoping this works. So all I'm doing is I'm just taking like the little tiny bit of sodium acetate that's left, and I'm just putting it on the plate, seed it, these tiny little crystals, and I'm hoping that I can pour this on the plate and get it to form like a sculpture. Let's see. Oh yeah. Oh yeah, it's working. Yes, success. That is so cool. And it's actually exothermic too, so it's really warm. The other thing that you can do with it is you can take a stirring rod with just the tiny little bit that's left, and you can scratch the edge of it, and it should, let's see if I can get it to see and crystallize in here. Let's see if I can get that to happen. I may have to add a tiny little bit of, let's see if I can scrape some in. Let's see, oh yeah, just a tiny little bit crystallized, and it looks like ice. It is not ice, it's warm. It's actually warm to the touch, but this is one of my favorite saturation and solubility experiments to do in school because it looks like icicles. You can see that very well. But yeah, it's super cool and it's very warm. And look at my little sculpture. This is sodium acetate crystals. I don't want to knock it over. It's pretty hard. That is really cool. You can make your own art. So what happened is when we heated it up, we allowed more to dissolve than normal. So if you remember my first video, when I first just mixed that little bit of water, it didn't all dissolve. And then when we heated it up, it did. So it became sort of, went from super saturated to fully saturated with that perfect amount. So you have to be really careful with your amounts. And as it cooled, it should lose the amount of solute it can dissolve. So the solubility would go down. But if you don't touch it, it won't actually come out of solution and sit at the bottom like it would if you just, if you added too much salt to something, to water, it'll just sit at the bottom. But if you don't disturb this because you've heated it up, it won't precipitate out until you bug it. And that might be based on seeding it, adding a tiny little bit more that it just can't take. And so it will all precipitate out. And again, it's exothermic because there's a lot of energy held in keeping it in that dissolved state when it's really super saturated, and it would rather be precipitated out. So it releases that energy when it's allowed to precipitate. And so, yeah, it's pretty warm. It's not hot, but it's warm. Should probably be wearing gloves. But yeah, that's really cool. It's like a nice crystal. So definitely try that out. Again, it didn't really work well with the baking soda and the vinegar, but if you can get, if the mentors and upper year students, you can get some sodium acetate. It's a really fun demo to do for grade 11 solutions too, solutions and solubility, and most high schools have sodium acetate to do, and I have a whole lab. So if you're interested in like having the whole lab from start to finish and doing all the saturation points, just send me a message and I can send it to you. So cool. This is my art. Probably won't be able to keep it. I'm worried my kids will try to like lick it or something. What does it look like? Looks like a chess piece. Very cool. Thanks for joining me on all of these demos. They were really fun.